Good morning, students. So, in the last lecture, that means in the Friday's lecture, we have covered the encoder, decoder, as well as the full adder part. So now, today we will see how the subtractor will work. And in a full adder, we have two inputs and two outputs. Whereas in for every input variables, there will be two outputs. Okay, whether it is two variable adder, three variable adder, four variable adders, we will have the two outputs. That is, one is sum and the second is carry. So similarly, for a subtractor, we have irrespective of the number of input variables, we have two outputs. One is difference and second is borrow. Difference and borrow. So let's see how it will work. So subtractor. So subtractor is digital computer performs a variety of information processing tasks. So for this we will use various arithmetic operations. So in this lecture we will cover the subtraction. So subtraction basically gives us the difference between the two variables, whereas in addition the second value is added to the first value, uh, whereas in subtraction the second value is removed from the first value. Like if we have 7 minus 2, now 2 will be removed from this 7. So when 2 will be removed, we will get answer as 5. So that means in this 7 and 2, the difference between 7 and 2 is 5. So basically this subtraction gives us the difference between the two variables which are subtracting with each other. That means for second variable to be equal to the first variable, we will add the difference in between them. Okay, so now see, let's see how the difference will work, or the subtraction part will work. So this is input A and input B. That means two variable input is there, and then we have subtraction and borrow. So here you can also write down difference and borrow. Okay, so see, we have first 0 and 0. So basically when both the terms are 0, this difference is 0, and we need not to carry any borrow to subtract the second value from the first value. See, can anyone tell me when we need the borrow value? When we need the borrow from the first value? No one. So we need borrow when the second value is greater than the first value. See, if we have 2, 1, this is 9. Okay, no, let it be 2, 1, and 6. And we have value 1, 9, 9. Okay, so see this this second value is greater than the first value, so we will borrow 1 from this side. Okay, so this is 16 minus 9, we have 7. Now again this is 9 and it will become 0, so we will again borrow 1 from it. So 10 minus 9, we have 1 and this is 1, so 1 minus 1 will become 0. Clear? And see if we have lower values like 7 minus 12, we have, what you can do is do this side and put the negative sign over here. Either when uh, mostly we use subtraction from this side, but in when the second value is greater, subtraction like this, and you will get the difference. That is minus 5 will be the answer. Okay, so this is it with the normal subtraction and division. So let's move on to the further. So next is 0 and 1. So basically it will become just, so it will become 1, difference is 1, but at the same time we need to borrow the value. Okay, so that is why difference is 1 and borrow is 1. In A1 B0, difference is 1, borrow is 0, and similarly in 1 and 1, difference is 0, borrow is also 0. Clear with this? Okay, so let's see the equations of it. So for uh, that means two variables are given, so that's why four inputs are there. So see here, 0 minus 0 is 0, 1 minus 0 is 1, difference is 1, 1 minus 1 is 0, and 0 minus 1 is, because basically it will become, it is not 10 minus 1, it is like 0, 1, 0 minus 1. Okay, so difference here is 1, and we need to borrow 1 from it, so 1 minus 1 is 0. Okay, so difference is 1 and borrow is also 1. See here, this is the part. In this case, difference is also 1 and borrow is 1. So the equation of difference will becomes like here. See the results of this D, it will be 0, 1, 1, 0. So which gate will give us the result of 0, 1, 1, 0? XOR gate. The symbol is like this. And similarly for D, we have XOR x or y. And for borrow, we will have this equation. This is in reduced form, b equal to borrow equal to x bar y. Clear? So this is the full subtractor. So we have 3 bits and two, basically it will become 2 power 3. So 2 power 3 means 8 inputs are there. So these are 1, 2, 3, 4, 5, 6, 7 and 8. So first of all 0, 0 and 0 we will have borrow 0 and difference is also 0. For 0, 0 and 1, so basically it will become 0, 1. So we will have borrow is 1 and difference is also 1. So then 0, 1, 1, 0. So we will have borrow 1 and difference 1. For 0, 1, 1, we will have borrow 1 and difference is 0. For 1, 0, 0, the difference is 1, borrow is 0. For 1, 0, 0, 1, difference is 0, borrow is also 0. For 1, 1, 0, again borrow and difference is 0. For 1, 1 and 1, difference is 1 and borrow is also 1. Clear? So this is the circuit of this. Uh, this is you can say that the block diagram of this full subtractor, and that will become the equation of this difference, that is b equal to x bar y bar z plus x bar y z bar plus x y bar z bar and x y z. And this is for the borrow, b equal to x bar y plus x bar z plus y z. So both are the circuits, and you can say that the diagrams of this difference and borrow. So I will just show you some videos uh, where we will have compared the results. Maybe you have done it in your DE subject. Let's see. Okay, so I will share the videos. Right now, I'm not able to share the sound with you. Okay, so I will share the videos of this half subtractor, half and full subtractor, as well as the adder. So